Hey guys, welcome to Biotorial. I am Mansi Joshi back again with another video on Newton's laws of motion. So in this video, I'll explain y'all what are the three important laws stated by Sir Newton. So guys, let's get started. So guys, starting from the Newton's first law of motion, which is also known as law of inertia. Why law of inertia? Because inertia itself means that whatever the object is doing, it will continue to do until certain force is applied. Whatever, if it is in motion, it will continue to be in motion. If it is at rest, it will be continue to stay at rest. Okay, so the first law states that an object in motion will stay in motion in the same direction. Okay, and an object at rest will stay at rest until any external unbalanced force is applied. So in order to memorize or learn about these laws, you all need to know the keywords. Okay, so in this particular law, the first law, the keywords are motion, same direction, at rest, and external unbalanced force. Okay, so let us first learn what this law states. So in this first picture, we have this soccer ball placed on the ground. Okay, and it is at rest. It is not moving at all. It is at rest. Until and unless if I apply certain force, it is not going to move at all. Okay, so it is at rest and it will continue being at rest until and unless I apply some amount of energy or force. Okay, so what if I kick this soccer ball from here? I am applying some amount of force by kicking this soccer ball. Okay, and the force applied is in this direction. So the soccer ball will go in this direction only. Understood? And in this second picture, we see that when this tennis ball is being thrown upwards, we see that it is going upwards to some extent, to some height, and then coming back downwards. Why is it coming back downwards? Because we have gravity which is pulling this ball downwards. Gravity is also a kind of force which is pulling this ball downwards. And in case if there is no gravity, okay, there is no gravity, then what do we see that we have this tennis ball, we are throwing this upwards, it is going to continue. It will go until and unless there is certain force which is going to stop it from going upwards. Okay, because there is no gravity, it is not going to stop. It will keep going in the upward direction. Okay, so this is what the first law states, that when any object is in motion, it will stay in the motion and in the same direction. We saw here it is in motion, this ball is in motion, and it will be in motion in the same direction. It will not change any direction. Okay, and if any object is at rest, it will stay at rest. Okay, this soccer ball was at rest, it will stay as it is until and unless external unbalanced force is applied. Okay, until and unless we apply or give some amount of force to this ball. Okay, so that simple is the first law of motion. Moving on to the second law of motion. Now this second law of motion can be explained in two ways. So in this slide I will explain it in a simple manner, and in second slide I will explain it in the terms of momentum. Okay, so here we have second law of motion saying that acceleration of an object depends on net force acting upon an object and mass of an object. So let us first consider the net force. Okay, they say that acceleration, that is A, is directly proportional to F. This particular sign is for directly proportional. Okay, this is proportionality symbol. So this is acceleration which is directly proportional to force F. Okay, what does this equation mean, or what does this relation mean? We have this cube over here, it is kept somewhere and it is not moving here. Okay, it is at rest. Now if I apply some amount of force here in this direction, then this cube will shift to this place. Okay, and it will achieve some amount of acceleration also. Now If I increase the force, okay, if I apply some more force to it, the acceleration will also increase. And in case if I decrease the force, I apply less force, then acceleration will also decrease. So that is known as directly proportional. Okay, the relation, the proportionality, it is directly proportional. If the force increases, the acceleration will increase. If it decreases, the acceleration will also decrease. Simple. Now coming on to the mass. Okay, so they say that acceleration A is inversely proportional to m. Now how can we write inversely proportional? So this is proportionality symbol, and whenever we say that something or some term is inversely proportional to another term, then what we are saying that this particular quality is inverse. Okay, we write it as 1 upon that particular quantity. Here it is mass. So mass is inversely proportional. We will write it as 1 upon mass. This means inverse of mass. Okay. So what does this relation mean? That this is inversely proportional. Now we have here two balls. This one is iron ball, the black one, and this one is some plastic ball. Both of them have equal size. Okay, the size is same. Now I am applying same amount of force, let's say F, to both. First to the iron ball and later to the plastic ball. Now we have the weight of this iron ball, say 10 kgs, and the weight of this plastic ball is 10 grams only. Okay, so the acceleration made by which ball will be the more? Which ball will attain maximum distance, cover maximum distance in same amount of force? It is the blue ball. Okay, so blue ball will cover maximum distance in this much amount of force, but the iron ball will just attain this much distance. Why? Because the iron ball is heavy, okay, which means that mass of iron ball is more. Mass is more. And here we have plastic ball and its mass is very much less. Iron ball was 10 kgs, whereas plastic ball is just 10 grams. So the plastic ball can cover more distance in just little amount of time. So we can say the acceleration made by this plastic ball, which is lighter, is more as compared to the heavy iron ball. Okay. So when the mass is more, the acceleration is less. Okay, so when mass is more, acceleration is less, and when mass is less, acceleration is more. So we can see there is opposite thing here. The relation is opposite, so we write it as A is inversely proportional to 1 upon m. Okay, so this concept is very much clear. Now what if I bring this both together? Here we have A as common here also and also here. Okay, so I will bring this together. A is directly proportional to F upon M. Okay, so I can write this way also. Or I can write this as A is equal to, removing the proportionality sign, I will put is equal to, and as we remove the proportionality sign, we get some constant here. Okay, that's the rule. Into F upon M. And this particular constant has value of 1. And that is why if we substitute this value of 1, simply we get is A is equal to F upon M, which can also be written as F is equal to M into A, correct? So this is the formula for force, which is equal to mass into acceleration. This particular formula is very much important in physics and very much useful in different applications also. Now let us learn this particular law, which is second law, in the terms of momentum. Okay, so let us first know what is momentum. This momentum is denoted in the letter P, with the letter P. Okay, so what is momentum? It is the product of mass and velocity of an object. Okay, which can be written as P is equal to mass into velocity. Okay, so we see that momentum is a vector quantity. What does that mean? Vector quantity means that it has direction as well as and magnitude. Okay, so we can say that momentum is vector quantity. Why? Because it has direction and magnitude. Now let us consider a soccer ball. Okay, it is kept over here, and when we apply some amount of force in this direction, what do we see? That this ball will attain some amount of motion and will change its place. Okay, it will attain some amount of velocity. So let's say the velocity over here is u, okay, at the initial place, and velocity when it reaches the final place is v. Okay, so now what can I say according to this particular formula? That initial velocity, initial momentum at this particular place, it can be written as p is equal to mass remains the same, but initial velocity becomes u. Okay, and similarly here also at this final position, what is the momentum according to this formula? P is equal to mass remains the same of ball into velocity at the final position, which is v. Okay, understood till here? Now we have to take the rate of change of momentum. Now how can we write the rate of change of momentum? The rate of change of momentum is the difference between this initial momentum and the final momentum. Okay, so I can write it as mu minus, sorry, not mu, it's mv. Okay, because the final velocity comes first. Likewise, final momentum will also come here first. Minus mu upon time t. Why time t? Because we are calculating rate, and whenever rate of any quantity is calculated, we have to calculate it with respect to time. So that is the rule. So we divide it with time t. And if I take here m as common, since they both have m, what I get is m v minus u upon time t. So we know that final velocity, that is v, minus initial velocity, that is u, with respect to the time is the acceleration. Correct? So this particular formula is for acceleration. So I can substitute this whole thing with a. So I'll write it over here, m a. So we get rate of change of momentum is equal to m into a. Okay, and according to the second law, now we can read the definition with respect to the momentum here written in yellow box, which says the rate of change of momentum. Okay, it is the rate of change of momentum that we found over here, which is ma, is directly proportional to applied force, and the change of momentum occurs in the direction of force. Okay, so we can write that F, that is force, applied force from here, is directly proportional to the rate of change of momentum, which is m into a. Okay, so again we will remove this proportionality sign and put the is equal to sign. We keep k as a constant, and then we have ma as it is. The value of k is 1. Okay, so we write it the final formula, that is force is equal to m into a. So what is m? M is the mass into a, which is acceleration. So in order to keep this in mind, you all should know the formula for momentum. Okay, it is p is equal to mass into velocity, and you all know this formula. You all can substitute over here also. You all can consider the initial momentum and the final momentum. Take the difference between both of this and take time. Okay, you all have to calculate with respect to time, and then only you all can get the rate of change of momentum. If you all just take this upper portion, then it is just change of momentum. It's not rate. Okay, this is just change in momentum, and when you all write upon t, it becomes the rate of change of momentum. Okay, because it is with respect to the time. So after calculating this, we take common. Okay, we take m common, and what we are left here is with is v minus u upon t. Okay, so this is the formula for acceleration. We simply substitute the acceleration and we get this particular answer. And according to the second law, force is directly proportional to the rate of change of momentum. So we take it over here. This is the statement. We remove the proportionality sign. We take the constant. Okay. And the constant has its value, that is 1. So we simply substitute it and this becomes our final formula. Okay. So that simple it is. Now moving on to the third law, which says that every action force has equal and opposite reaction force which acts simultaneously. Now, this law is also known as law of action and reaction. Okay, so in order to understand this particular law, we will consider these two examples. Okay, so in this first example, suppose I took a spring here. Okay, we have metal springs. So suppose I took one of them, and I tried to apply force with my finger downwards. Okay, in the downward direction, I'm applying some amount of force. Okay, so I applied that force. Now the spring has been compressed, and later on, as soon as I leave my finger, I stop applying the force, I'll see that this spring is bouncing upwards. Okay, it is bouncing in the upward direction. Why is it so? Because when we apply some amount of force, that a force is applied in certain direction, and later on it is released in the opposite direction, and with the same amount of force that we had earlier applied on it. Okay, so this spring will bounce upwards in the same amount of force. So we here see that the force is same but the direction is opposite. Okay, so when we consider the second example, we also notice the same thing. Now this boy is playing basketball over here. So he threw this ball in downward direction. Okay, so this ball is going in downward direction. So as soon as he touches this ball touches the ground, what happens that it is going to bounce in the opposite direction, which is in upward direction, and with the same amount of force which was applied by this boy. Okay, so let's say that this boy applied F amount of force on this ball. Okay, so this ball will strike this ground, and this ground will exert same amount of force on the ball but in the opposite direction. Okay, so the force is transferred from ball to the ground, and now the ground will exert same amount of force but in the opposite direction. Okay, so this is how this third law takes place in our day-to-day life. You all can also try some other examples while playing or just observing around yourself. Okay guys, so that was it. So guys, that's it for today's video. If you all have any kind of doubts, you all can just place it in the comment box. I'll try to solve it in comment or make another videos on it. Okay, so like this video, subscribe to our channel, share it with your friends. Until then, this is Mansi Joshi signing off.